All right, so the next thing we're going to take a look at on our periodic table are some of the general areas, general sections of it, and then we're also going to be taking a look at some specific areas of the periodic table. And as we go through it, I will notate on this black and white version where these different regions are. Um, and you can think of it as sort of being able to navigate uh, around the periodic table. Again, this is probably the most useful tool we're going to see in the chemistry part of the course. So being able to interpret it and extract the relevant information is going to be really, really critical. So the first thing that we want to consider here is generally what we're going to see on the periodic table. I'm going to highlight these. Let me see if I can get a picker. So these elements that I'm highlighting that are in the green shaded color. And so all the way down this way. All of this. And so these, probably maybe can get looking these are all metal. Everything that's green here, the three rows, and then we've got 2% to that. We'll get what these in a second. The green color region, these are metal. The ones in yellow, yellow, this way. The phosphorus, argon, all those all of them yellow. These are not metal. No, those things in yellow, those are non-metal. Right, and then we're going to look at the pink ones, and that'll be boron, silicon, germanium, arsenic, antimony, aluminum, aspartame. Those, the ones that are known as metalloids. Sometimes they're called semimetals. So the first general trend here that we want to note in the periodic table, I'm going to finish up this designation. The first thing to note here is when you look at the periodic table generally, we consider the metals. So the things that are in green are generally found on the left side of the table. What we can also say is that the non-metals are generally found on the right side of the table. And then in between the metals and the non-metals, you have your metal. So on this particular periodic table, it had this thick zigzag line here that sort of serves as the line of demarcation. So to the left side of that, you have your metals. To the right side, you have your non-metals. And the elements that sort of straddle or hug that zigzag line or that staircase right? Those are your metalloids. So boron, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine, those are known as metalloids. So that's generally, it's the first way that we can interpret the periodic table: metals to the left, non-metals to the right, and the metalloids are kind of in between. That's a very simple designation, but it's also very, very, very important when it comes to how these different elements are going to combine later on. So knowing whether it's a metal or a non-metal actually is the starting point for all sorts of things. Bonding, or how they come together, and also how we name some of the resulting compounds are going to depend on what types of elements you have in a particular compound. Right, so that's the first thing that we want to keep in mind. So we have metals, non-metals. What are some differences between them? So let's take a look at some general differences. Metals here tend to be solids. Not always, but they generally tend to be solids. They usually are hard and crystalline. And again, these are generally, or general characteristics. There are always going to be exceptions. We're just looking at sort of a broad overview of this. And they also tend to have fairly high melting points, so high entry for melting points and high boiling points as well. Metals, as you also probably know, generally also tend to be malleable. Okay, that means they can easily be turned into like sheets. So think about an aluminum foil sheet or a gold foil sheet or whatever, metallic sheet that you have. And they can also be ductile, meaning that you can turn them into wires very easily. Okay, so malleable sheets very easily, and then ductile wires can be drawn into wires. Think about copper, for example, which is right there. Copper wires, very easily formed. So those are some general characteristics of your metals. Your non-metals usually have characteristics that are a little bit opposite to those. Your non-metals, they can be in any of the physical states. They can be in all three solid, uh, liquids, gases. They also have generally tend to be lower melting points and boiling points compared to metals normally. And then they usually are not malleable or ductile. And then if you compare both of those to the intermediate category for your metalloids, right, these would have properties that are intermediate. The metals and non-metals. So let me back up a second. One of the characteristics of your metals that you probably know of is that they also tend to be good conductors of both heat and electricity. Again, think of a typical metal like iron or aluminum or copper or something. Right, like burn copper wires. We have copper pots and pans at home. Whereas your non-metals tend not to be good conductors, instead they tend to be insulated. These are not good conductors. Opposite of that is insulating. Which then means if we're dealing with metalloids that have properties that are intermediate, well, what's intermediate between a good conductor and a poor conductor? Well, something like semiconductor. Good example of that is something like silicon. That's probably the most common semiconductor there is in most of your electronic devices. Silicon is very, very important. And it's silicon, by the way, not silicone. That's a very different thing. All right, so those are some general properties of metals, nonmetals, metalloids, and where you tend to find them in the periodic table. You're looking at the periodic table, you might see, for example, that there's one element that kind of sticks out. It doesn't seem to be in a location where it's supposed to be, and that's hydrogen over here on the left side. It's yellow, it's coded yellow in this case, which means it should be a non-metal, or it is a non-metal, and it should be over here on the right side with all of its friends, but it's not. And the reason why it's over here on the left in the same column as the element below it is that it actually behaves. It has some characteristics chemically that are more similar to these than it is to the non-metal. So that's why you see it over on the left side rather than with the other non-metals on the right. And again, these are general trends on the periodic table. There are always going to be exceptions. Hydrogen is a good example of one of those exceptions.